Hello everyone, Mr. Fawcett here, and we are back with part 2 of our lesson on the chain rule using e to the x and natural log of x, or ln of x. The first part of this lesson I think is going to be a treat because I'm going to show you how to use the calculator to find derivatives. So let's scroll down to this page right here where it says finding values of derivatives using the graphing calculator. So you can use the calculator to find a derivative when you are evaluating the derivative for a certain number. So if they just ask you to find the derivative and you need to find the general derivative as in the function, like if you just need to find f prime of x, the calculator is not going to do that for you. Now if you need to find f prime of 6, well, if it's a calculator portion of your test or exam, you can use the calculator to do all that work, and you don't have to work out the derivative by hand. The calculator will do that for you. So again, it's another efficiency tool that we have when we're allowed to use it. Okay, so we're just going to do a couple of these together, then you can do the rest of them on your own. We also are going to talk about what the derivative means in reference to the original function. So we're going to start off with f of x, that's equal to 3 times e to the x times sine of x. So if you have your TI-84 or graphing calculator with you, let's pull that out. And I'm going to bring up the calculator on my screen. Okay, so when we are trying to take a derivative on a calculator, again, we need to only attempt this when we're evaluating the derivative for a specific value of x. So if we come back here, we can see that we need to evaluate this derivative at -2. So let's go back to the calculator. Let me show you how to do that. First thing we're going to do is we're going to go to the math button. Hit math. We are going to go all the way down to the bottom, and you can just go up if you want until it goes to the bottom. And we're going to go to option number 8, nderiv, or nderive. I'm going to hit enter. Okay, a couple things we need to be aware of. This first d over d with a box, you need to enter the variable for which you're taking the derivative with respect to. In this case, it's x because we're talking about a function of x. We're talking about f of x. In the next set of parentheses, you just enter your function. So I have 3 times e to the x times sine of x. Oops. There we go. You do want to make sure your calculator is in radian, so let's just go and make sure we are in radian mode. We are. You do not want to be in degree mode. And then I can go back. So I'm just going to go second quit. Brings me back to my home screen. Now I need to enter what value I want to take the derivative at. Well, in this case, it's -2. So I'm just going to enter -2. Once you've entered all that, just click the enter button. And the value of this derivative is -0.538, regardless of whether we truncate or round. So we could come back to our screen over here. We're going to type in our value, so we get -0.538. We should say approximately equal to because it wasn't exact. And they ask us a question. They say, is f of x increasing or decreasing, or does f of x have a horizontal tangent or a vertical tangent? Well, if our derivative is negative, that means that the tangent line has a negative slope, which means the function is decreasing, right? Since f prime of -2 was less than 0, f of x is decreasing at x equals -2. And again, for this one, you might be able to get away with just saying increasing or decreasing, but it's good practice to write out the justification. It's good practice to write out why it's increasing, why it's decreasing, why it has a horizontal or a vertical tangent. Okay, number 2, we're evaluating the derivative at x equals 1, or a equals 1. They're just saying a is equal to x. So we come back over here. I'm going to have to get rid of this so you guys can see my calculator properly. And I'm just going to go through it again so we can walk through the steps one more time. So again, we go to Math. We go down to option 8, and derive, hit enter. The variable that I'm taking the derivative with respect to is x. The function is 3 times e to the x times sine of x. And again, make sure your calculator is in radian mode. And then x equals is what you're evaluating the derivative with respect to. In this case, it is what you're evaluating the derivative at a certain x value. So in this case, our x value is 1. That is where we are evaluating. And then I just hit enter. And in this case, our derivative value is 11.268, truncated or rounded. So I'm going to come over here. We've got 11.268, again, approximately. And if our derivative's positive, so since f prime of 1 is greater than 0, f of x is increasing at x equals 1. So you can go through and you can do the rest of these. I just wanted to give you a couple of examples of how to take the derivative on your calculator. You can imagine that this would be not a terribly complicated derivative to take. It would just be a product rule, but it would take you some time, right? And if you're on the calculator portion of an exam, you certainly want to save as many minutes as you can to save them for the problems that require a lot of work. And if you're spending extra time doing this by hand when the calculator could do it for you, well, then we're not being super efficient. So look for opportunities to use the calculator. You, of course, need to know how to do these derivatives by hand, but sometimes the calculator is allowed, and when it is, we should take advantage of it. Okay, let's erase this and see what the next page brings us. All right, so it says here, when the value of a derivative of a function is positive, we say that the function is increasing. That was not my best. Let's try that again. Increasing. A little better. When the value of a derivative of a function is negative, we say that the function is decreasing. And again, those are just relationships we've talked about for a couple of units now. When speaking of quantities increasing or decreasing, they can do so at a certain rate. We already understood the derivative to be the slope of the tangent line, and slope is a rate. Thus, the derivative of a function represents the rate at which the function is changing. So we can think about it. Let me draw you two examples real quick. Say we have two functions here. We have a function like that. We'll call that f of x. And we'll call this function down here g of x. And let's pick the point. We'll just call this x equals a, x equals a. Right, so if we draw a tangent line at x equals a for both functions, we notice that the tangent line is positive for both, right? Which means both functions are increasing when x is equal to a. However, the purple one, that slope of the tangent line is much steeper than the slope of the tangent line on the red function at x equals a. So we would say the purple function is increasing at a faster rate than the red function at x equals a. So that's just what they're talking about when they say the derivative of a function represents the rate at which the function is changing. Okay, let's now apply this concept to a word problem. it says, let me erase this actually, and let me scroll up. I'm actually going to put all 3 questions together so I don't have to keep scrolling up and down. We'll just get rid of 2. We're not going to do that one in this video. Okay. So it says the number of people at a concert can be modeled by the function f of t, which is equal to 560 times e to the power of sine of t, where t represents the number of hours after the gates are open. So people are going to a concert. This function lets the people in charge know how many people are at the concert, a certain number of hours after they open. So part A says to the nearest thousandth, find the values of f of 1/2 and f prime of 1/2. Using correct units, explain what each value represents in the context of this problem. So we need to find f of 1/2 and f prime of 1/2. This would be a calculator problem. Okay, they're not going to expect you to do this by hand. That would be made clear. It would either be in the non-calculator section or the calculator section, or they would specify whether it's allowed or not. But I'm letting you know now that you are allowed to. So let's think of ways that we could use the calculator to efficiently check what these 2 values are. Well, again, if we just need to find the value of f when t equals a certain value, we can just substitute right into the function. So I'm going to pull up my graphing calculator for us. All right, so here's our graphing calculator. I've already entered the function into y1, so now we can just use it. So I'm going to go back to the main screen. And we need to find f of 1/2 or f of 0.5. So one way you can do that rather than having to retype the function in every single time is once you type it into y1, you can go to alpha, trace, and you can go down to whatever option your function was in. Right? Ours was in y1, so we'll press enter for y1. And then in parentheses, put the value that you want to evaluate the function at. So y1 of 1/2. We punch that in, and we get the value of f of 1/2. Now again, you can round to the nearest thousandth, or you can truncate to the nearest thousandth, either one. I will round. Yeah, I will round. So let's write this down, and then let's think about what it means. So f of 1/2 is approximately equal to 904.482. But this is a word problem, and units are important. Let's get a little better 9 there. Okay. So what do our f of t values represent? Well, t values represent the number of hours after the gates are open, and the f of t values represent the number of people at the concert. So this is approximately the number of people, a little over 904, that we could expect at the concert half an hour after the gates are opened. So after gates have been open for half an hour. And you could put 30 minutes, you could put 0.5 hours. The key thing here, though, is that you include people, and you say that's the number of people after the gates have been open for that amount of time, half an hour. Okay, now we need to find the value of f prime of 1/2. So we talked about this before, just earlier in this lesson. But if we go back to the calculator, right, we can let the calculator take and evaluate a derivative for us. Right, so we're going to go to math. Going to go down to option 8 and derive. Hit enter. Okay, we're going to take the derivative with respect to x, because that's what our function was entered into the calculator with. Now you could just type out the function again, but we already have it saved in y1. So I'm going to go alpha, trace, hit enter when I'm at y1, and then we are evaluating at 1/2. Hit enter, and we get 793.757. So we take that value, we write it down, and then we think about what does that value mean? So this is not going to be a number of people, right? Because we're at f prime, we're not at just f. If you're confused about finding units for the derivative, one thing that I like to do is I like to think about what the derivative is, right? It's the slope of the tangent line. Well, the slope of the tangent line, if we think back to what slope means, it's really just the change in y over change in x. So if we are finding a slope, it's going to give us some number, but it also holds true for the units. So the units for our y values or our f values for the original function were people. And our x values, or in this case our t values, were hours. So our units, and again, there'd be some number right here, right? It doesn't matter what that number is, the units are going to be the same. Our units for the derivative here are people per hour. Okay, that means this is the rate at which people are entering or leaving the concert at a certain t value. In this case, since our f prime value is positive, we know that people are entering the concert at this rate. So we can say 793.757 people per hour is rate at which people are entering the concert at the time t equals 1/2. Okay, so again, we come up with a number, but then we explain what that number represents, because these numbers did not have the same units, right? So we need to figure out what the units on the original function are and what the units on the derivative are to give a full explanation. Okay, I'm going to erase that just to give us some more space. We are going to move on to part B. Part B says, how many people are at the concert 2 hours after the gates are opened? So let's think, do we need to know the original function's value at t equals 2 or the derivative function's value at t equals 2? And this goes back to knowing what the units are for each function. Well, if we're talking about how many people, that is an f of t value, so the original function. So for B, all we have to find is f of 2. So we hop right back over to our calculator. Again, I'm using my original function, so I go alpha, trace, hit enter, and I just enter 2 for my input. And that is going to give me that value, approximately 1390.24. And again, all round, so I'll go 0.244. Oops, did not want to quit out of there, but that's okay. Yeah, make sure approximately equal. And our units are people. Again, on the AP exam, you don't have to round to anything other than 3 decimal places unless they specifically ask you to. You don't have to try to think, well, there are these units, so maybe I should round to the nearest whole number. Nope, on the AP exam, 3 decimal places always rounded or truncated unless they specifically say something different. Okay, on to our part C, our last part. It says, is the number of people at the concert increasing or decreasing 2 hours after the doors have opened? Explain your answer. So we know how many people are at the concert 2 hours after the doors have opened, but we don't know if people are leaving at that point or if they're still coming in. So think about, does the original function or the derivative give us the rate, right? We want to know if there's a positive or negative rate of people entering or leaving. Well, if it's positive, they'll be entering. If it's negative, they'll be leaving. But we need to find the derivative value, so f prime of 2, to know what that rate is, to know whether people are still entering or whether they have begun to leave. So final time back to our calculator. Let me move this over here. We're going to be taking another derivative, so we're going to math, option 8. Taking the derivative with respect to x, we are going to alpha trace to enter our function because that is in y1. And we are evaluating at x equals 2. So our value here is negative 578.545. So we can write that value down. Negative 578.545. So since our derivative is negative, and we want to show that, we just would want to put this is less than 0. Thus, the number of people at the concert is decreasing at t equals 2. And this just goes back to our original function derivative relationship, right? If they're asking is the number of people increasing or decreasing, they're asking us is the original function increasing or decreasing? Because the original function, f of t, talked about how many people were at the concert. So again, to figure out whether the original function is increasing or decreasing, you need to figure out whether the derivative is positive or negative. So that's what we did, and then we wrote a justification. Okay, this wraps up this lesson. Again, there are more problems to practice in the packet, so attempt those. Write down any questions you have so we can discuss. Enjoy the rest of your day, and I will look forward to seeing you next video.